3, then 3 squared, that's 9. Minus 7 times 3, that's minus 21. Plus 10. The 9 and the 10. The 9 and the 10 will give me 19. And 19 minus 21, that's what? Negative 2. And negative 2 is actually less than 0. Alright, so any value between 2 and 5 will make the expression less than 0. Let's try a value that is outside. So let me use a number line here. So we have this 2 and we have 5. So any value between 2 and 5. Notice 2 will make the expression 0. 5 will make the expression 0. What we want is the values that would make it less than 0. So any value between. So we tried 3 and we tried 4. Let's try a value that's outside the solution set here. Let's try 1. If we try 1, we substitute 1. 1 squared, that is 1. 1 squared is 1, right? Minus 7 times 1, that's minus 7. Plus 10. What is that? The 1 and the 10 give me 11. 11 take away 7, that's 4. And is 4 less than 0? No. Alright? So 1 will not be a part of the solution. Let's try 6. If I try 6 squared, that's 36. Minus 7 times 6, that's minus 42. Plus 10, let's calculate this. The 36 and the 10 would give me 46. 46 minus 42, that's positive 6. Now is positive 6 less than 0? No, it is not. Alright, so notice that the solution set would be the set of numbers that lies between 2 and 5. Anything outside this interval here actually make the expression more than 0. We want only the values that make the expression less than 0. Which brings me to another point now. What if we were asked to solve this equation? Let me just separate it here. X squared. What if this was a problem? X squared minus 7x plus 10 is greater than 0. What if that was the problem? Then the same critical values, because when we factorize again, we'll get x minus 2, x minus 5 greater than 0. And you equate both brackets to 0 and solve, you'll end up with the same critical values, 2 and 5. What would be our solution set? And as a general rule, when the quadratic expression is greater than 0, the solution set is x is greater than the larger critical value. In this case, the larger critical value is 5. And x is less than the smaller critical value. And the smaller critical value is positive 2. Good? And that would be your solution set if it was greater than 0. So greater than 0, solution set, x is larger than the higher critical value, less than the smaller critical value. If the quadratic, as in the first case here we looked at, is less than 0, then the solution set is x is between the two critical values, less than the smaller one, greater than the larger one. Good. And that's basic of another quadratic inequality, 2x squared minus 3x minus 5 less than or equal to 0. Now again, the first thing I want to do is find what we call the critical values, whatever values that would make the expressions of x that would make the expression 0. And so we can factorize again. So we can rewrite the minus 3x, which two numbers add to give minus 3, and multiply to give minus 10, which is what AC is. And those numbers would be positive 2. So negative 3x can be written like that. And then we have our minus 5 here. Let's factorize. So the first pair, factorized by a group, common factor there is 2x. So we'll have x plus 1 in the bracket. The second pair, the common factor there is minus 5. And again, x plus 1 in the bracket. And you can just quickly expand just to make sure you have the correct factors. So, common factor, x plus 1. Outside, we have 2x minus 5. And again, to get the critical values, we equate each of these brackets to 0. And you solve. Good? So the critical values are, if you equate this to 0, you get x equal negative 1, right? And if you equate 2x minus 5 equal to 0, then 2x equal to 5. So x equal to 5 over 2, or 2.5. In other words, if you should plug any one of these values into the quadratic, it will make it 0. Alright? So, because we're dealing with a less than situation here, just separate this. We have a less than situation here. Solution set is given by, since it's less than, x is between the two critical values. But we have to keep the sign, less than or equal to 2.5. So it's less than this larger value and greater than the smaller value. So in other words, if you plug any value that lies between negative 1 and 2.5 in the quadratic expression here, it would make it 0 or less. So if you plug negative 1, it will make it 0. If you plug in 2.5, it will make it 0. And any value in between, minus 1, here's the number line. Any value in between minus 1 and 2.5 will make it, the entire expression, 0 or less. And then anything outside of this now, let's say this was a problem you were given. Let's say this was a question that you were given. So the same quadratic expressions, same expression, hence the critical values would be the same. So a solution set, again, sorry, I wanted to put greater than. So a solution set with x would be greater than or equal to, since it's or equal to, the larger critical value, which is 2.5. And x would be less than or equal to the smaller critical value, which is minus 1.